All right, welcome. Thanks for coming over. There's a lot of great talks, so I really appreciate you guys choosing this one. My name is Andres, and I'm here to talk about code risk management at Twitter. All right, so let's get started. So you probably heard about this. If not, I'll tell it real quick. Over the Oscars, Ellen DeGeneres that was hosting got down with the audience and did an epic selfie that just broke the previous retweet record by like 3 times. So I thought it would only be fair if we try the Fluent Conf epic selfie. So if anybody would like to join an epic selfie over here, that would be awesome. You guys can come over and like we can, yeah. Sweet. Oh, sorry about that. All right, awesome. Yeah, we're making history over here.
What's your username so we can tweet it?
Yes, at Andres at the bottom, Andres. That's kind of small, but you'll see it in a second as well. Okay. All right, so that was great. All right, so before we start talking about code risk, we have to define what code risk is, just so we're all on the same page and we know what we're talking about. So code risk is the probability of including defects while writing code. Now, defects is obviously any unexpected behavior. It could be bugs, it could be performance degradation, any type of behavior that we did not plan for it to be there. Sorry about that. Yeah. And I highlighted there writing code because that's where defects are born. We do lots of things to catch defects later on, but code risk talks about, you know, when they're born, what's the probability of more of them being there. Okay, so what kind of code risk are we talking about at the scale of a company like Twitter? Sorry, give me a second here because there's a way to show my presenter notes and 1 second, sorry. All right, whatever, we'll just wing it. Okay, so just to give you an idea of the scale that we're talking about at Twitter, this was one of the first offices that we had. This is Twitter around 2008. We're on the 4th floor of this building, and there the company grew from about 8 employees to less than 100. A few years later, we moved into our Folsom office, which we started on the 6th floor and then expanded to the 3rd floor, and then expanded to the 1st floor, then started bumping elbows with other companies in the building, and we grew to around 500 employees at that point. And then this is Twitter today. On our market office, we have several floors there, and we have now offices all over the world, around 2,700 employees, of which about half of them are engineering. So what kind of challenges this raises for code risk? Well, there's growth of the engineering organization is at a pace that the risk keeps increasing. There's also the projects that keep growing inside. You know, there's much more amount of code that is being shipped and developed and all the time. And with that comes, of course, the rate of change of the code. And there's also always the need for more testing. There's no matter how much automated, manual, different kinds of suites, different test environments, you always need more testing. And the interesting thing about all these things, all these risk factors, is that they can all be measured. Now keep this in mind for what we're talking on the demo later on. Okay, so how do we manage all this risk, right? What sort of techniques do we have available? So there's pair programming, right? I'm sure you're familiar with this. It's, you have an extra, yeah, it's my daughter, by the way, 6 weeks old. You have an extra pair of eyeballs on the code, right? So then you mitigate some risk there. Then there's also like code reviews, which it's a kind of like asynchronous pairing. Someone else looks at the code at some other point in time. You have testing, of course, and you have refactoring. Now refactoring is arguably the most complicated of all of these because it takes a lot of effort and a lot of work to get some value out of it. And so I'm going to dive in a little bit more into refactoring. It's worth talking about it a bit more. So refactoring is improving the structure of code without changing the functionality. And without changing the functionality is critical because as soon as you start changing the functionality, then you're adding new features and there's more risk involved at that point. So you want to limit your code changes while doing refactoring to just improve the structure of the code in different ways. Now, there's lots of benefits of refactoring. Among them, there's increased productivity because once your code is in a better state, it's easier to read, it's easier to maintain, you're churning out features quicker. There's also a decreased ramp up. When you have someone else join the team, it's easier for them to become familiar with the code and start becoming productive. It's also easier to test by definition. Well-written, testable code, it's easier to test, and then it's easier to maintain as well. But there's also challenges to refactoring. If there was only those benefits, then we'd all be doing it all the time. The problem is that refactoring is only tangible to those familiar with the code, right? So if you go up to your manager or to a director and you say, hey, I'm going to spend 2 months refactoring, and your manager's like, okay, how many new users are we going to get from that? What's the new features that we're going to get? It's like, no, nothing. We're just going to improve the code. It's really hard to justify that. Because it pulls resources from feature work, right, which is what we're trying to get out the door. It's also very hard to prioritize and to estimate and to set goals because there's this untangible benefit to it that you don't know how much you should spend doing it. So it usually just keeps accumulating as technical debt until it becomes this huge project, and if you leave it long enough, they become rewrites, right? When it's writing new features in a code base becomes so complicated that you just have to wipe it and start it over again. Okay, so from this we see that if you want refactoring to be effective, it has to be proactive more than reactive. You have to be ahead of the game and be able to plan for it, see how much you should do it, measure the benefit of doing it, and that's why we create a tool to do this. We call this tool histology, which turns out it's a science, the study of microscopic structure of tissues, including feathers. So, Twitter is everything bird-related, so of course. So this tool basically gathers several metrics and calculates the risk of modifying each file. I'm going to dive into much more detail over this, but the idea is, remember in the beginning, all the risk factors that I mentioned that could be measured. So this tool does that and then puts them all together, normalizes the data, and basically tells you where in your code base you should focus your refactoring attentions to, and then what you can measure the benefit of that because you have a number to change, right? So let's dive into a demo. Okay, let me turn on mirroring. Okay, I guess we'll do it this way then. All right. So we kind of build different views for this tool. This is kind of like the central point where we launch off, and this view here, the risk histology, basically summarizes. These are sample projects. This summarizes how your risk distributes across all your projects that you have here, right? So the green bars represent the amount of code in that code base that are low risk. The yellow bar represents medium risk, and the red bar represents high risk. So you get a very quick overview of, okay, you see here that Albatross has 39% of the code that is high risk, right? So we can dive into that to know more. And I'm going to get into more detail of how we gather this data in a second, but just to show it to you. So for example, you see here the Albatross project. Here's the distribution. You can see a little description of what does it mean to be low risk. There's no need to refactor there. Medium risk, you need to have more caution when modifying this part of the code. You might start thinking about refactoring. And high risk is you want to, let me see if I can zoom that a little bit. It gets crazy. All right. High risk is you want to start refactoring that if you want to prevent bugs from keep popping up in this area of the code, right? So the charts you see down here are the different metrics that we gather and the distribution of the values for those metrics across the project. So the blue lines show all the files in the code base, and you can see like how the churn of the files is, of the size. There's some other metrics. Here I'm gonna switch projects. And then, so we gather all these different metrics and then put them together to compile this risk one, right? So let me dive into a file here. So for example, let's just open this one up. So once you select a file, because this is all indexed to a file, and we made a decision so that you had a granularity that you could see, okay, if this file is high risk, we can do some refactoring into it. And an obvious example is you have a very large file, right? You split it up, and now you have 2 smaller files. Now modifying each of those 2 smaller files is much less risky because you don't have to keep all that code in your head while you're touching it. So this file, for example, it gets highlighted in each of the different other metrics to see where it is, and then you can start painting a picture of why this is high risk, right? It falls on the 100th percentile of organizational distance. I'll explain what this means. So one of the most interesting metrics is organizational distance, which is this one right here, which there's been a lot of research done into how your organization is spread out versus how that organization works in the code. So the more cohesive your organization is to your code base, the better quality your code is going to be, the less risk there's going to be, right? So we measure what's the distance between all the people that touch a certain file, and we basically put them all in a line, right? Like all the committers of the file, and then count from one committer to the next, how many jumps in the organization, how many managers you have to jump through to get from one to the other. And then you do that for each 2 committers until you end up with a distance. And that's that number over there. And then we break it down while we're measuring that. We can see, all right, means 13 teams, and you can see which ones there are there. And there's 16 developers, right? So as soon as you see something like this, you know that there's something to fix right there. If there's 13 different teams touching a single file, there's something wrong there. This already, the organization grew, but the code structure stayed the same, which in places like Twitter that happens a lot. So at this point, directors, the executive team can make decisions based on this, on what to do about it. And we have a lot of visualizations for that I'll show you in a second. Churn, for example, is, to go into another metric, is how many modifications have been done to this file in a certain amount of time. Size is just the number of lines in the file. Exposure is the converse of coverage. So what's the percentage of the file that is not covered by unit tests? And that inversion is done so that all these metrics, the higher the metric, the higher the risk. And bug fixes is how many bugs have been fixed on this file in amount of time. Now this is fixed, not bugs found, because when you have a bug that you found, you don't know where it maps to in the code until you go and fix it. So you can increase the time frame of it to get more data there, and then that correlates into this risk. We also have another way of visualizing the code base, which is a tree map, right? So once you select a code base, it breaks out all the directories in organized by size according to the risk, right? So you can get an idea of where the risk falls. Each blue box is a directory, and each purple box is a file. So you can see within this directory which ones are the riskiest files, and then you can select that one, and you see where it falls, and you see all the details. Okay, so now let's go into a little more detail of how we gather all this stuff and how it works. So the first is, how do we calculate the risk, right? Like, I've been talking about risk, and I've been talking about this number, but what does it really mean? Well, to calculate risk, there's 3 steps involved. First, we do a collection phase where we gather all the different metrics. And then we have a normalization phase where we transform each of the metrics, which is a raw number, just like 5 bug fixes, into a hazard, which is the risk represented by that metric. And we do that so that we can then aggregate all those different hazards into the risk. So diving into each one of those a little bit deeper, the collection phase involves going through each of the metrics that I mentioned, and each one of these takes a completely different way of doing it. We architected this project so that you can add or ignore certain metrics. We did it, we did a modular design where if you don't need any of these metrics or they don't apply to you, you just don't use them. In one of the projects that I just shown, some of them were missing. You can also expand it if, for example, for your domain, compile times are really important, right? You know that if a file is increasing compile time, then developing there is something that's going to be more painful. So you can add another module and plug it in. Now, in the normalization part, this is where it starts getting, a little bit more on the math side. Is we basically run these numbers through a sigmoid curve, which looks something like this, and each of the metrics has a different sigmoid curve depending on the range of data that you expect. This one, for example, is the one for exposure. So from 0 to 100% of exposure, we move the offset and the slope so that it makes sense for your particular project. So here we're saying, from 0 to about 30% exposure, we don't care that much. The risk won't go more than like 20%. But once we go between 40 and 70% exposure, then that growth of the risk there should go steeper. And then after like 75% exposure, it's pretty much top risk, right? Like at that point, you're talking about you don't have test coverage for that file. So each of the metrics goes through a similar process, just with different offset and slope. And we made all this configurable so that, for example, if you're going through a refactoring phase and there's going to be a lot of churn in the code, then you can move the offset and slope to make sense for that higher expected churn. And then the aggregation, which basically once we have each hazard, we multiply them by a weight, and that's the last piece that you configure, like how much of your risk do you attribute to each of the metrics. So going again to the example where you anticipate you're going to do a big refactoring, you want to lower the contribution, the weight of churn, because it's going to churn a lot, and it doesn't mean that the risk is higher. You're improving the code, you're changing it. So the interesting thing about this tool is we built it with the intention of having a way to measure and plan and then see the benefit of refactoring. But the interesting thing is, along the way, when we started gathering these metrics and this data from like day one that we gathered the simplest one, which is size, we started noticing. So this is the original goal, but we started noticing that there's all this different usefulness of just knowing this data, right? So refactoring is an obvious one that I already mentioned. There's also the technical debt prioritization, but then there's other things like quarterly progress tracking, right? As soon as we started seeing this, we knew that we could have very, very easily, we could have a way to see how far projects have advanced each quarter. We also, another very surprising use is the team reorganization that I was mentioning. So basically from the organizational distance metric, we build this visualization where each circle is a developer, each larger circle is a manager, and each box is a code base. So we were able to map out how our engineering organization overlays with how our code is distributed. And that was very valuable when doing reorganizations, when realizing that certain projects were becoming these huge monoliths that we wanted to avoid. So this just opened up a bunch of different insight into the sort of things that you can improve just by gathering some data, right? So even if you take from this talk, I'm gonna just run a command line to sort my files by size. You may get something out of it, right? You may get some value, and then you can put that, like, knowledge of, yeah, everyone knows that it's a pain to work on that file. Well, why is it a pain? How much is it a pain? How much more than these other ones? Once you improve it, like how much less pain are you going to have? And that's basically the gist of it. So thanks a lot for coming to this talk. We have a Twitter booth in the exhibitor hall. If you want to chat more, or if you're interested in working on Twitter, you can always come and talk to us. And if there are any questions, the mics are open. Yeah, if you could walk over to the mics, yeah, so that people who are on the, watching online can hear.
So you showed those, cool graphs that represent the theories that you have about certain risk. For example, exposure has this parameter, right? And that's how you know how risky that certain matrix is. But how good does all those theories map to reality?
Right.
Have you tried, running some tests?
Yeah, that's a great question. All this data is a snapshot in a single point in time, right? What we're working on right now is seeing, now that we have this data and we've started tracking it, how that is affected throughout time. Like bug fix is a good example, right? Like that tells you how many bugs you have found, but it doesn't tell you, all right, the risk tells you we found this many bugs. There's no correlation there until you go to the future and then you see, okay, we knew back then that this file was high risk, and then this same file 3 months later has had this many bug fixes, and then you can find correlations. And the beauty of it is, if you don't find those correlations, you have all these knobs you can pull to adjust it to see how you can how you can adjust the model to reflect reality, right? So if you notice that, hey, risk has nothing to do with how many bugs were found or the satisfaction of working in that code base or whatever other validating metric that you have, then you can move the knobs and introduce new modules, or you can change the weights. You have all these different levers that you can pull to do that. Eventually, you want to get to the point where we have artificial intelligence doing that for you, right? Like just learning from it, going back, adjusting it, and then you can have a model that you can say, this is a truth. Right now, like you said, it's theory, and we have a snapshot. It's a starting point to get to that. Yes?
I was wondering if there's any value to, or if you're already doing, assigning risk to how important the functionality the code touches is. Like, it's worse to break all of Twitter tweeting functionality than it is to break editing a user's first name or something.
Yeah.
Do you consider that, or do you think it's better to just keep it as code metadata?
No, yeah, that's actually a good point, and that speaks to the granularity of the data, right? So you're talking about not all bugs are the same, and you're right. If you bring the site down, that's kind of like a stronger consequence than just like breaking a link. So yeah, that's something else that we've thought about doing. That's definitely something that as we add more metrics or improve on the metrics that we did and that we will do. But yeah, it's a good point. It depends on how you track your bugs. That's why we didn't do it right off the bat, because many different teams, don't even assign severity to bugs, right? So it will be a moot point in a lot of those, but it would be definitely valuable, and then you can assign different weights to it. An easy way to do it would be to have a different one. You have bug fixes, but you also have incidents, for example, and then you could track it as a separate thing that weighs heavier than bugs. Oh, sorry, you have a question.
Yeah. Looks great. When are you guys going to open source it?
Yeah, thanks for asking that question. Actually, I was working on open sourcing it, and then I left on paternity leave. And then, so I can't make any promises as to when, but it's something that we definitely have planned. And shoot me an email or a mention or something, and I'll be sure that you find out when that happens.
Did you have to change the way you work to get this system to work? For instance, like how do you report what is a bug and what is an improvement, what is refactoring?
Yeah, that's another good question. So ideally, no. Ideally, you want to do the lowest common denominator of what everybody does, and then from there, people can add modules that just apply to them. But when you get to a certain size of organization, you need that kind of standard across, right? Like in the maybe even just a year ago, the way people track bugs was completely different. Now we're doing all this work to standardize that, for this and many other reasons. So for the people who are working on trying to standardize that process, this is another motivation to say like, hey, if you follow what we're, the way that we want you to track bugs, you also get this benefit. So it's kind of like validating that you need somewhat of a standard way of doing it. But yeah, the goal is to be the least intrusive so that you don't have to say, yeah, this is great, but now you have to do your releases this way or something like that. I have another question.
So you talked about the organizational distance, which was cool. Mm-hmm. The organization is going to change over time. Are you taking snapshots of what the org structure was 2 months ago when person A committed compared to now when person B commits to calculate the org distance? Yeah, so what we do is we find out what the organization is at every point in time that we gather metrics. So we always consider the organization at this moment. But yeah, that's a caveat of that is if you move teams, then suddenly all the code you touch goes up in risk, which if you think about it, kind of makes sense. So, we went back and forth of whether to keep track of that, normalize that in a different level to account for it. But in the end, we're like, let's start with it this way. And, maybe it makes sense that if you split a team apart, all that code is higher risk. So that's what we currently do right now. Thanks.
Hey, I was wondering if you can give us more examples of ways you make code less risky. Like you gave the example of saying, we reorganize our teams in order to reduce that one factor. Mm-hmm. But can you give us examples of if you find out a code is risky because of bugs or because of churn or size, like what kind of steps you take in order to reduce the number of files that are high risk? Right.
Yeah, as we use this tool, we're starting to find those patterns. Because, it's interesting because it's a case-by-case basis, but then you start noticing patterns, right? Like I gave a few examples, like you said, but others are like, basically any change that you do that will lower any of those risk factors or metrics will lower the risks. So, for example, I gave the example of size. Another obvious one is, well, if you have a lot of exposure, add more tests, right? That's going to lower the risk. But you also find this interesting cases where, for example, one of the first times I sorted the files by risk and opened up the riskiest file, I noticed that one of the main reasons that it was risky was because it was huge, and then everybody touched it. And when I dived into the file, it became really obvious why. And the reason is that it was made of a bunch of inner classes. And pretty much each team kind of touched each class more or less separately, but they were all mangled into this huge file. So, that validated the point that you don't want to have a bunch of inner classes in a big file. So you take it case by case, and then you start finding these patterns, and then you can generalize and make just like recommendations just in general that's supported by data now. Okay. If there isn't any more questions, sounds like we're ending right on time. So I'll be over at the booth right now if you guys want to chat more, if you have more questions. Thanks again for showing up. Thanks for participating in the selfie. Thanks a lot.